Hello everyone. Okay, Siddharth, Abhay, Aneri, Anika, Sakshi, Ralam, Vadehi. So today's topic is equilibrium. Okay. So chemical equilibrium. आज मैं टेस्ट आपको सेंड नहीं कर पाया. In the next class I will definitely send. Means tomorrow. Okay. So today we are going to start chapter 7 of class 11, that is chemical equilibrium. अब ये equilibrium का literal meaning क्या है? You know, there are so many reactions which are not going to be means they are not go to completion, like reactant to give product. It is like this. So that means if reactant is completely converted into product, there is no need of this term. But there are many reactions that do not go to completion, means they proceed to some extent, leaving considerable amounts of unreacted reactant. Means in the final stage there is reactant as well as product, both are present. Means the resulting mixture has both reactants as well as product. So when such a stage is reached in the course of the reaction that no further reaction takes place or apparent, it is said in chemical language that reaction has attained the state of equilibrium. Means where the composition of the system become fixed. Means at equilibrium, कब बोलेंगे उसको equilibrium? When there is no apparent change in concentration. Means जो concentration of reactant as well as concentration of product, they are fixed, they will not change at that point. Means there is no apparent change in the concentration, and the sign is like this. Okay. So at equilibrium state, both forward and backward reactions, they move with the equal speed. Means it is like this. See, if we have like say rate versus time, rate versus time. So say with the time, what happened? The forward reaction, this is forward reaction and this is backward reaction. With the passage of time, rate of forward reaction goes on decreasing and rate of backward reaction goes on increasing. See, it is like this: rate of forward reaction, rate of backward reaction. So with the time, rate of forward reaction goes on decreasing and rate of backward reaction that goes on increasing, and a stage is reached where they are in the equilibrium state. This is equilibrium state, this is rate of forward reaction and this is rate of backward reaction. So at equilibrium, rate of forward reaction becomes equal to rate of backward reaction. Means speed is same. That means rate of disappearance of reactants is exactly equal to the rate of appearance of reactants from the products. See, reactant is disappeared to form the product and product is disappeared to get the reactant back. That's it. This is called dynamic state. In chemistry, we are dealing with dynamic equilibrium only. We are dealing with dynamic equilibrium. Okay. So, you know, chemical reactions, they are of two types, reversible and irreversible, right. There are two types of chemical reactions, that is reversible and irreversible. Now, what do you mean by, first tell me, what do you mean by irreversible reactions? Yes, anybody? Irreversible reaction. So, irreversible reaction means which takes place only in the one direction. That means it is like this, reactant is converted into product, means the chemical reaction which proceeds in such a way that reactants are completely converted into products. That is the reaction which move in one direction, that is forward only. Reaction which moves in forward direction only. Okay, that is called irreversible reaction. Or in such a reaction, products do not react to produce reactant back. Okay. Yes, 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 very good. So now you can say that reaction, that means this reaction does not move in the backward direction. Okay. For example, if we have barium chloride and when it react with sodium sulfate, then when they are mixed together, reaction occurs and we get barium sulfate as a PPT. We get barium sulfate as a precipitate, okay, along with NaCl. So, reaction between barium sulfate and NaCl, that is backward reaction, is not possible under this experimental conditions. So, in such reactions, the arrow, see this arrow, okay, is placed between the reactants and products, and this arrow indicates the direction of the chemical change is from reactant to product. Okay, single arrow is there only. Okay, got it? There are so many other reactions of irreversible nature. In such reaction, there is no equilibrium state, like say ammonium nitrite. So, if we decompose it on heating, it give N2 along with 2H2. So, this is also irreversible reaction. Any precipitation reaction, see like silver nitrate with NaCl, you know silver nitrate test for chloride. So, we get AgCl as a PPT along with sodium nitrate. Even neutralization reactions, you know neutralization reaction, like if we have H2SO4, it is a strong acid, you know, when it react with strong base, you know this is strong acid and sodium hydroxide is strong base, then we get sodium sulfate along with H2O. So this neutralization reaction is also single step reaction, means it is irreversible in one step, means in only in one direction. Even magnesium, when you bond magnesium with oxygen, we get magnesium oxide, then dazzling white flame, है ना. So from MgO we cannot convert it back to Mg and O2, right, under the experimental conditions. If we change the conditions, it may happen. Like if we have ethanol, we burn ethanol, okay, so we get carbon dioxide and water. So from carbon dioxide and water, we are not able to prepare back ethanol, okay. So these are irreversible reactions. I think it is clear to you that what are irreversible reactions. Now reversible reactions. Reversible reactions. So reversible reaction means which takes place in both directions under similar conditions, that are called reversible reaction. So कौन से reactions which takes place in both direction, means forward as well as backward, means reactants react together to give product and products can react together to give reactant back. So in such reaction, products also react with each other to produce reactants again. Let us take an example. Suppose we have magnetic oxide, okay. So when it is reduced with hydrogen, okay, when hydrogen is passed over heated magnetic oxide, then what happened? We get iron and water, iron metal and water, right, 3, 4 and yes 4, okay. So in this reaction, what happened? If steam is passed through iron, powdered iron, at the same temperature, then we get back magnetic oxide along with hydrogen gas. So that means such a reaction is reversible, okay. So if this type of reaction is carried out in a closed vessel, obviously in no case the reaction is completely in one direction, it is not completed, okay. So either of the two reactions can take place independently. If the steam or hydrogen is allowed to escape from the system, है ना, the open, if vessel is open, है ना, then what happened? If steam is allowed to escape out, then it may become irreversible. If hydrogen is escaped out, then it may be in the one direction. But if vessel is closed, then and nothing is allowed to escape, both forward and reverse backward reaction can take place in the vessel. So reversible and irreversible. In case of reversible reactions and involving gases, vessel should be closed. That means such a reaction we can write like 3Fe plus 4H2O to give Fe3O4 plus 4H2. So we write it like this. So such a reaction which proceed in both directions and do not reach to completion, they are called reversible reactions. So reaction going in the from left to right, that is called forward reaction, and reaction going from backward to forward, that is called backward reaction, forward and backward reaction. Okay, so this sign indicates the reversibility of the reaction. Okay, like if we have 2HI, so 2HI is in equilibrium with H2 and I2. So means 2HI can be converted into H2 and I2, and H2 and I2 can react to give HI. Even if we have PCl5, on heating, you know, two axial bonds break to give PCl3 and Cl2. Okay, and PCl3 and Cl2 react to get back PCl5. N2 and 3H2, they react together to give 2NH3. Okay, or SO2 can react with O2 to give 2SO3, right? Even NH4HS, ammonium hydrogen sulfide, है ना, that give ammonia and H2S, and ammonia and H2S react together to give back the same product, है ना. So these are all reversible reactions. So what do we mean by irreversible reaction? Which goes in one direction only, means that reaction which is completed in the course of the reaction. With time it will be completed, but reversible reactions are those which can proceed in forward direction as well as backward direction, and they do not reach to completion. यस बेटा, यहां तक किसी को कोई डाउट है तो प्लीज पूछ लो. समझ आ गया रिवर्सिबल एंड इरिवर्सिबल रिएक्शंस? यस बेटा बोलो. बेटा कोई डाउट है तो पूछ लो एक बार. हाँ बेटा, अच्छा नो डाउट, बट सर वो इक्विलिब्रियम की डेफिनेशन एक बार. ओके बेटा, देखो इक्विलिब्रियम मीन्स कि ऐसा कोई भी रिएक्शन, अभी मैं आपको एक बिल्कुल क्लियर कर देता हूं, ठीक है ना. चलो ये वाला टॉपिक लेते हैं, है ना, तो आपको क्लियर हो जाएगा. स्टेट ऑफ केमिकल इक्विलिब्रियम, है ना. तो केमिकल इक्विलिब्रियम के स्टेट जो है ना, हम बात करते हैं कि जैसे मान लिया ए रिएक्ट विद बी टू गिव सी प्लस डी. सो सी ए एंड बी आर रिएक्टेंट्स, सी एंड डी आर प्रोडक्ट्स, ठीक है. अब बेटा जो रेट है, कीप इन माइंड रेट जो है दैट डिपेंड्स अपॉन कॉन्सेंट्रेशंस. तो फॉरवर्ड रिएक्शन जो है, ये फॉरवर्ड रिएक्शन है, तो फॉरवर्ड के लिए क्या चाहिए? कॉन्सेंट्रेशन किसकी चाहिए? रिएक्टेंट्स की, ठीक है. और बैकवर्ड के लिए किसकी कॉन्सेंट्रेशन चाहिए? प्रोडक्ट्स की. तो रेट ऑफ फॉरवर्ड रिएक्शन दैट इज आर एफ is equal to, yeah, that is proportional to concentration of A into concentration of B, ठीक है. Beta, you can ask but not now, because chemical equilibrium is going on. Okay. So rate of forward reaction is equal to forward rate constant, because constant of proportionality is there. So Kf is forward rate constant. So say what happened when reaction goes in the forward direction, then concentration of reactants goes on decreasing. See, we will start with reactants. Okay. So initially concentration of reactant is maximum. So rate of forward reaction is maximum. Okay. It is molar concentration of reactant A. See the value in square brackets. Okay. It means molar concentration of reactant B. A is molar concentration of reactant A and B is molar concentration of reactant B. Okay. Now come to backward. See, as the reaction proceed, product is going to form. So rate of backward reaction, that is RB, is proportional to concentration of C and concentration of D. Okay. So now RB is equal to backward rate constant, concentration of C, concentration of D. So here Kb is constant of proportionality for backward reaction, that is called backward rate constant, and the C and D is molar concentration of products C and D. Molar concentration of products C and D, right? So this is second. So at equilibrium, you know, when I draw this diagram, see rate versus time. Initially, you know, you will start with A and B, then it leads to the formation of C and D. Okay. So as we start, there is only forward reaction, backward reaction is not coming into picture. Why? Because product is not formed. Initially we start with reactants only. Okay. That's why there is rate of forward reaction only. Backward reaction is nil. But as the time passes, what happened? A and B goes on decreasing. So that means rate of forward reaction decreases because concentration of A as well as B decreases, because reactants reacts together to give product. So whatever happened to product, concentration of product increases. So that means rate of backward reaction increases and concentration of C and D increases. Okay. So in this way, see rate of forward reaction, it decreases, and rate of backward reaction, rate of forward reaction decreases and rate of backward reaction goes on increasing. A stage is reached where rate of forward reaction becomes equal to rate of backward reaction. This stage is called equilibrium. after that equilibrium is there, okay, because rate of forward reaction becomes equal to rate of backward reaction, okay. Means at equilibrium rate of forward reaction is equal to rate of backward reaction. That means Kf A B is equal to Kb C and D. Okay. So, Kf over Kb is equal to concentration of C over concentration of D divided by concentration of A, concentration of B, and that is called another constant K, and this is called equilibrium constant. This is called equilibrium constant, okay. This is called equilibrium constant, ठीक है. Yes बेटा. Okay, Ralam got it. Great. So in this way equilibrium constant is forward rate constant, ratio of the forward rate constant to the backward rate constant, and it is also defined as, yes, it is also defined as ratio of the product of the, yes, equilibrium constant is, it is the ratio between the product of the molar concentration of products, product of the molar concentration of products to that of the product of the molar concentration of reactants, with each concentration term raised to a power equal to stoichiometric coefficient in the balanced chemical equation. So that is called equilibrium constant. So what is equilibrium constant? The ratio between the product of the molar concentration of the products to that of the product of the molar concentration of reactants, with each concentration terms raised to their stoichiometric coefficients. For example, if we have small a moles of capital A reactant, small b moles of capital B reactant, to give small c moles of capital C product plus small d moles of capital D product, then equilibrium constant that is K. This is actually called Kc. Why? Equilibrium constant in terms of concentration. It means equilibrium constant in terms of concentration. So that is equal to concentration of C into concentration of D raised to power CD divided by concentration of A into concentration of B raised to power small a small b. So that is called, this is also called law of equilibrium, or it is also known as rate of ratio किसका, of the rate constants of the forward reaction and backward reaction. Okay. For example, if we have 2 NO plus O2 to give 2 NO2, is it balanced? 4 4, yes. Suppose this is the reaction. So what is the equilibrium constant for this reaction? Kc. Why I write Kc? It is equilibrium constant in terms of concentration. So that is equal to concentration of NO2 raised to power 2 divided by concentration of NO raised to power 2 concentration of O2 raised to power 1. Okay. Kc equal to concentration of NO2 raised to power 2 over NO raised to power 2 into O2 raised to power 1. Okay. Got it? कर लोगे? Laws of chemical equilibrium. See, rule number 1. Suppose A to B. Okay. Equilibrium constant is K1. So that is equal to B over A. Now we reverse it. Okay, rule number 2. If we reverse it, then equilibrium constant is A over B. That implies it is 1 upon K1. That means if you reverse the reaction, equilibrium constant is inverse of that. Rule number 3. If we multiply it with 2, with any number, then it becomes B raised to power 2, A raised to power 2 means B over A whole raised to power 2, that is K1 raised to power 2. That means if we multiply the equation by any number, then equilibrium constant becomes power of that, K1 raised to power that particular number. If we divide by any number, again same case, B raised to power 1 by 2, A raised to power 1 by 2, that is B over A raised to power 1 by 2, that is K1 raised to power 1 by 2, right? Then if we have A to B K1 and C to D let us take K5, K1 B over A, K5 D over C. So when we add them, then A plus C, B plus D. So K6 becomes, yes, it become B into D over A into C. So that is B upon A, D into C. That means K1 into K5. So if we add the equations, equilibrium constants are multiplied. Equilibrium constants are multiplied. Now let us subtract. A to B, C to D. So when we add them, subtract them, it becomes A plus D to B plus C. A plus D to give B plus C. So K1 equal to yes, it is again K5, that is D to C. Okay, but now say D is on the reactant side, we are subtracting these two. So equation become K7 equal to B into C over A into D. Means just play with the equations, okay, nothing else. So B upon A is K1 and it becomes divided by K5. That means if you subtract the equations, equilibrium constants are divided, right. K6, okay, beta, in K6 when we add the equations, then equilibrium constants are multiplied. If we subtract the equations, equilibrium constants are divided. Okay, Abhay, got it? Yes, Abhay. When we add the equation, see A and C are added, B and D are added. So equilibrium, net equilibrium constant is product of these two. But if we subtract, see A as such and D is there, okay, B and C, that means second equation is subtracted from the first one, then it is like this, right. Okay. So let it be up to this today, okay. I will send one question, you will complete it and send to me back, okay. ओके बेटा, सो ये सारा कंप्लीट कर लेना आप लोग अप टू दिस. These are the all the laws of chemical equilibrium, okay. So done. Okay, bye beta.